Good day, and welcome to another episode of my reviewer series for civil engineering topics focusing on fluid mechanics problems. For this episode, a 90-degree triangular channel having a roughness coefficient of 0.012 carries water at a rate of 6 cubic meters per second. With the given conditions, we are to determine the following: the critical depth of flow, the critical velocity of flow, and the critical slope of the channel. For this problem, let's talk about critical flow muna. When we say that a flow is in a critical state, this is when the gravity and internal forces act in balance, thus making it seem like the flow speed is regulated. And upon determining the actual state of the flow, meron tayong condition na sinusunod, which is reference to a value na tinatawag nating Froude number. So when we want to get the critical flow of a channel, the value of this number must be exactly equal to 1. If it is less than that, yun yung tinatawag natin subcritical flow, wherein yung characterized velocity nito is on the lesser speed. On the other hand, if the value of Froude number naman is greater than 1, then yun naman yung tinatawag natin na supercritical flow, wherein ito naman yung flow na may greater speed. Bale, to state simply, yung critical flow natin is yung flow na may balanced velocity lang, while yung subcritical flow naman is mas mabagal, then yung supercritical flow is mas mabilis. So, moving to how to determine a value for the Froude number, we just follow the general formula of Fr equal to square root of q squared times t over a cubed times g, where q stands for the rate of flow, t stands for the top width of the water surface, a stands for the cross-section area of the channel fluid, and g stands for the acceleration due to gravity, which, as usual, has a magnitude of 9.81 meters per second squared. Now na may grasp na tayo sa concept, move forward na tayo sa pag-solve ng problem. So ang unang hinahanap is yung critical depth. For this case, yun yung nakadenote ng letter D sa ating figure. And in order to determine that, let us just use our equation for Froude number and express natin yun in terms of depth D. So given tayo ng value na 6 cubic meters for the rate of flow Q. And based on the figure, unknown ang top width and area dimensions natin. So to solve this, express muna natin both variables in terms of D. Para dito, gamit lang tayo ng geometry. Looking at the triangle, pwede tayo gumawa ng relationship based dun sa given central angle. So if we are to apply trigonometry, we can look at this figure in a way na pag hinatin natin yung triangle exactly at the middle, ang magiging angle nito at the base is half of 90, which is 45 degrees. And using that with the dimension D na nasa side ng divided triangle natin, and the dimension na half of T sa top width, we can express the half of the top width with the trigo function na tangent theta equal to opposite, which is half of T, over the value of D. Simplifying this equation, we know that the value of tangent 45 is just equal to 1. Therefore, in order to express T in terms of D, let's just multiply both sides by D and also by 2. With that, we can see that the value for T is just actually twice of D. Moving on to determining the area in terms of D naman. Alam natin na ang area ng triangle is equal to 1/2 base times height. So if ipa-plug natin si top width as the base, then yung height naman natin is yung depth ng channel, we would be able to express the area as 1/2 times 2D times D equal to the square of D or D squared. Now that we have our variables in terms of D, pwede na natin siyang i-plug sa fluid number equation. Solving for the value of d, using fluid equation, dapat equal to 1 siya to get a critical value. With that, we will get a critical depth of approximately 1.5 meters. Next up, solving for number 2, in order to determine the critical velocity, gamit lang tayo ng general formula na Q equals AV, or rate of flow equal to cross-section area times velocity of flow. So yung Q natin is equal to 6 cubic meters per second. Tapos yung area naman natin is, as of kanina, equal to d squared. Solving for the velocity, we will get a value of 2.7 meters per second. Now, for our last unknown, gamit lang tayo ng flow equation. So hopefully familiar pa kayo. Ang tinutukoy ko na equations kasi is yung kila Manning, Darcy-Weisbach, and Hazen-Williams. Magkakaiba ng approach ang ginagamit sa mga flow equation na ginagawa nila due to difference in used coefficients. Pero lahat sila, same lang na nagre-relate ng hydrodynamic properties. For this problem, since di tayo given ng specified flow equation reference, idedepende na lang natin yung pagpili ng formula sa kung ano yung mga meron tayong given values. Showcasing our flow equations, ito yung mga general formula that we need to keep in mind para if ever na di-specified sa problem, magre-relay na lang tayo sa present variables. And going back to the problem, ang mga variables na meron tayo na distinguishable is yung roughness coefficient na 0.012. And being familiar with these equations, alam natin na ang usual denotation ng roughness coefficient is the variable n. Therefore, for this case, ang gagamitin natin na formula is yung Manning's equation. So moving forward, plug na natin yung present values sa formula natin. V is the velocity, wherein yung nasolve natin kanina yung gagamitin para critical value din ng slope makuha natin. And S equal to 0.012. And yung R naman, yan yung tinatawag na hydraulic radius, wherein in order to get its value, we just have to divide the cross-section area of the fluid by the wetted perimeter of the channel. So for this case, yung area natin is 1/2 times base natin na 2d times height natin na d. Then for the wetted perimeter, we just have to consider these two slants na pwede natin makompute by using Pythagorean theorem. So, considering na yung mabubuo nating right triangle on the half side of the whole triangle has lengths both equal to d, we will get a slant value of d square root of 2. And multiplying it by 2, since both sides yung included, we will have a wetted perimeter of 2d square root of 2. Now that S is the only remaining unknown, finally we are able to answer our last question, which has a slope value of 0.0025. So that's it. Our situation is finally solved.